All right, so today we're looking at trigonometry on the Cartesian plane. Cartesian plane has got broken down into four parts, which are called quadrants. We have our first quadrant, which is between 0 degrees and 90 degrees. So all the trig ratios are positive. Sine, cosine, and tangent are all positive in the first quadrant. The second quadrant, which is between 90 degrees and 180 degrees, only sine is positive. Cosine and tangent are negative. In our third quadrant, which is between 180 degrees and 270 degrees, only tangent is positive. In our fourth quadrant, between 270 degrees and 360 degrees, since we have made now like a full revolution, only cosine is positive. So remember this acronym, ASTIC. First quadrant, all trig ratios are positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And fourth quadrant, cosine is positive. Now, you must remember whenever you're dealing with questions of trigonometry on the Cartesian plane, you'll be dealing with right-angled triangles. All right, so you must remember the Pythagorean theorem, right? Remember, you have your hypotenuse, your opposite, and your adjacent. So in this case, remember, your hypotenuse will always be represented by r, your opposite will always be represented by y, and your adjacent will always be represented by x. Right? Remember, the opposite is just opposite the angle. So wherever you see the angle is, the side that is opposite, that's the opposite. And we take it as y. So we've got 2 points here. We'll start with this point here, 6 and 8. We want to find sine theta, cos theta, and tan theta. So we get our point, 6, 8. We first make our Cartesian plane here. Our x coordinate is 6. Our y coordinate is 8. So our point is here. So once you get your point on the Cartesian plane, draw a diagonal to the origin. All right. There's our point here, 6, 8. Once you draw the diagonal to the origin, make a right angled triangle. All right. So theta is here. So we need to find, so before we do that, so our x, our adjacent is 6 units long, and our opposite is 8 units long. So we need to tabulate our hypotenuse, which is r. So if you remember the Pythagorean theorem, r squared equals, let's make some space here, r squared equals x squared plus y squared. Right? So to get r, we have to get the square root of these two. So x squared is 6. X is 6, so we say 6 squared plus y is 8, so we say 8 squared. So 6 squared, that is 36. 8 squared, that is 64. 64 plus 36, that is 100. So the square root of 100 is 10. So we found our r, which is also our hypotenuse. And remember, r, y, and x, whatever quadrant you be on, they'll still stay on the same positions. So our hypotenuse, which is r, is 10. So now we can begin. So for sine theta, Remember, sine is opposite over hypotenuse or over h. Let's look, we refer to our triangle here. All right. Our opposite is y and the hypotenuse is r. So we say sine theta is equal to y over r. So y is 8, r is 10. So we can say sine theta is 8 over 10. You can leave it as a fraction if you want. You can get a decimal and get the sine inverse to get the value of theta. But for this example, I'll just leave it as a fraction. So we can simplify this fraction. 8 divided by 2 is 4. 10 divided by 2 is 5. So sine theta equals 4 over 5. All right, now let's tabulate cos theta. So remember, we are in the first quadrant. So sine, cosine, and tangent are all positive. So cosine is adjacent over hypotenuse. We refer to our triangle. Adjacent is x, and our hypotenuse is r. So you're going to say 6 divided by 10, which can be simplified to 3 over 5. And then finally, we can get tan theta. So tan is opposite over adjacent. So if we refer to our triangle, opposite is going to be y and adjacent is x. So you're going to say y over x. Y is 8. 8 is 6. And simplify this further. Going to be 4 over 3. So for our first coordinates, 6, 8, we have determined sine theta, cos theta, and tan theta. We can now go to our second coordinate, -4, 3. All right, so you're going to draw the Cartesian plane. So since the point is -4, 3, so our for our x coordinate here is going to be -4. Our y coordinate here is 3. So we are in the second quadrant. So once you get your point, draw a diagonal to the origin and make a right angled triangle. So the opposite, so we have theta here. Opposite is going to be 3. Adjacent is going to be -4. So we need to determine the hypotenuse, which is r. All right, so we're going to say r equals square root of x squared plus y squared. So x squared, that is going to be -4 squared. Y squared is 3 squared. So -4 squared, that is 16. 3 squared, that is 9. 16 plus 9, that is 25. So get the square root of 25, which is 5. Now, remember our acronym. We're in the second quadrant, so only sine is going to be positive. Cosine and tangent are not going to be positive. So let's tabulate sine theta, cos theta, and tan theta. So sine theta so here we can just write y, x, and r. So sine theta is opposite, which is y, over hypotenuse over r. So y is 3, our hypotenuse is 5. So sine, as you can see, is positive. Cos theta, which is adjacent, which the adjacent is x, over hypotenuse r. So x is going to be -4, r is going to be 5. And then tangent is going to be opposite y over x, opposite over adjacent. So y is 3, x is going to be -4. So our tan theta is going to be -3/4. So this is where we'll end. See you in the next video.